everyone. I wonder where I can mount that compressor at. Well, I'll look at that after we do the podcast.
Dial of Destiny shows that some relics should just stay buried. Ouch.
It's amazing that there's reviews for that already.
It's just critics.
Still, that's a month and a week away. It's 5 weeks away.
Well,
I'm surprised they're...
the good news, it's not as poor as Indiana Jones and the Kingdom of the Crystal Skulls. The bad news, it's not much better.
Really, the only thing that's really bad about... You know, it's been a while since I've seen that movie.
Crystal Skulls?
Yeah. I really think the only thing that's bad about it is that some of the CG is just really bad. That's really, I think, my only problem with it. And some of the set pieces are bad. Like the monkeys swinging in the trees.
The part with the ants was stupid.
No, the ants are that's a normal Indiana Jones thing, though. I thought it was fine.
I don't know. I don't think the ants were.
All the bugs from Temple of Doom. The pit of snakes in Ark. And then
Covenant, yeah.
what was the one in the third one? What was all the gross? Oh, it was the sewer rats in the third movie. So they all have like gross creatures that like are like swarms. It's kind of like a staple of Indiana Jones. Now I'll say this: the CG for the ants was not very good. So I will agree there. But it, as a concept, is fine.
Looks like Tears of the Kingdom is starting to come down just a little bit.
Oh,
Like, it's like the initial reviewers came out and all gave it 5 stars, and now I've been looking at it like it's trickling up the lower stars.
well, the lower stars, everyone's just complaining about like it's on the Switch. That's all they're complaining about.
I'm reading them right now. There's more than that, but yeah, yes.
I'm honestly surprised how well it does run on 6-year-old hardware. That was already old when it came out.
It has, in my opinion, it has more frame rate drops than Breath of the Wild did,
Oh yeah, for sure.
because they just put more in it. I'm seeing more people dog it for being too close to Breath of the Wild, basically. But it's like a sequel, you know?
Okay, I think we should just go ahead and start.
Yeah.
Five, four, three, two, one. I guess we're recording now. Does it say it's recording on your end?
It does.
Cool.
It
Okay.
also says I'm uploading.
I guess that's a good thing.
Yeah, no, it does that. This service seems to progressively upload, such that by the time you click end, I'm already at like 99%.
Awesome. Welcome to the Macrofab Engineering Podcast, a weekly show about all things engineering, DIY projects, manufacturing, industry news, and the simplest SMT component in the world. We're your hosts, electrical engineers Parker Dillman.
And Stephen Craig.
This is episode 380. So this week we're going to be talking about the CNC machine, I hope this time, that Steven's been working on.
We're actually doing it this time.
Yeah, it's actually number one on our list to start, so we will get to it. Unless there's a sidetrack that takes 55 minutes, because that's happened before. And then in my newsletter that I got from Mauser this morning, it is the simplest SMT component in the world. And then maybe get to some projects I've been working on as recaps.
So the CNC, I've got some updates on it. It kind of sat for a while I was accruing some parts.
And cooking crawfish.
And cooking crawfish, which happened last Friday. Parker actually flew up here. In fact, Parker got to see the CNC. But yeah, Parker flew up and we had our crawfish boil, which was a big success. There was a lot of people. We had a ton of fun. And I still have trash bags full of crawfish shells that I gotta get rid of.
Surprisingly, because of how cool it is at night in Denver, Colorado, it honestly didn't start stinking at all, really.
Yeah, I went out to the garage where they're at just before this podcast, and it doesn't smell terrible, but you could tell that there's something there.
Something is starting to ferment a little bit.
Yeah. So yeah, the CNC. Basically, what happened was I built my CNC up to the point where it was a frame that sat on the floor. Everything was bolted together, but none of the drive electronics were on it. The enclosure for all the electronics hasn't been done, and none of the cabling has been done. So it's basically just a frame sitting on the floor. So really, in my mind, I kind of split this project up into two phases. The first phase was mechanical, get all the mechanical just like bolted together in there, and then electrical, and I'm starting the electrical side of things now. So it's funny, when I wrote the notes for this show, I wrote it 3 weeks ago, I think, at this point, and the first thing on there is I got my 2,000 millimeter ball screws right before the episode. Well, I got those 3 weeks ago now. So the 2,000 millimeter or the 2 meter ball screws that I got are for the long direction on the CNC. I have a dual X drive, so 2 motors in the back that drive this, and those are both of those 2 meter ball screws. Across the Y direction, inside the gantry, I have my other long ball screw, which is 1,950, so it's basically 2 inches shorter than those other two. I bought them at separate times. And I bought the Y-axis one first, and when it first came in, it was incredibly tight to fit into the bearing blocks that I have, and it kind of didn't leave a good feeling in my stomach for buying the other 2 ball screws on it because of how tight it was. Luckily, when I bought it, when it arrived, it had actually snowed the day before. So in order to get it into the bearing blocks, I just went out and put the whole ball screw in snow to kind of shrink it a little bit, and then took my heat gun on my reflow, my solder reflow, and tried to warm up the bearing blocks. I had to use a little bit of percussive maintenance to get the ball screw to seat in the bearings. Probably a little more than I should have. I mean, I know you're not supposed to beat on a bearing with a hammer, but a mallet. I'll use the word mallet.
That does sound better, by the way.
It does. Mallet doesn't seem as destructive, right? Although I was using a socket to hit the mallet onto the bearing. So it's about as bad as you think it was. But luckily I sent it home. It's probably never coming off those bearings ever again. But it doesn't feel crusty, and I've already put a caliper, a dial caliper on it, and spun the ball screw, and I'm seeing about 0.02 of an inch per stepper click, basically. So I don't feel like I've totally, beat up those bearings too bad on the Y. But for the X, the 2,000 millimeter ball screws that I got in, they came in, they slipped right into the bearings. So the machining on these, basically all I'm saying here is the machining on these ball screws that you get are probably not fantastic. They don't look bad, but they just didn't seat. One of my three didn't seat well in the bearings. So I was worried about that with the long X direction. Luckily, I got away with it. So got both of those in. I've installed one of them on the machine for just testing purposes, and so far, I've only had, out of this whole project, I've only had one oopsie, shall we say. And it actually isn't even an oopsie. It's just, I opted to have the machine oriented such that my stepper motors were on the back side of the machine as opposed to the front side of the machine. And the reason why is because they protrude out of the frame a bit, and I didn't want to walk by and just like rack my gut on
You didn't want it what's called a belt loop catcher.
Yeah, totally. Because the way that the stepper motors mount to the frame, they have a good solid 8 to 10 inches that they stick out. And I guarantee you I would be walking by one day and just, catch a belt loop, or worse, just like rack your gut into these things. And I just didn't want them. So I opted to build the machine backwards. So all that means is that if you think of how the gantry mounts to the frame, the gantry is flipped 180 degrees. But if you flip the gantry 180 degrees, then the ball nut carrier that actually is the connection to the gantry, that gets flipped 180 degrees, and it caused interference with one bolt. So my ball nut carriers have 6 bolts that connect to the ball screw itself. I had to omit one of them because it interferes. I don't think that's going to be a problem, but that's the first and so far only oopsie that I have, where it's like, I could probably grind some stuff down and make clearance for that extra one, but I think I'm just going to omit that bolt because, like I said, it's 1 out of 6 bolts that are all in a very tight pattern right next to each other. 6 is probably way more than enough anyway. You could probably get away with just 2. And I'm not really loading this thing down super hard, so I'm not concerned about that. But given the complexity of what this thing is, having the frame go together and having everything just be Legos on the first go, I'm okay with just one oopsie so far. So that's the X ball screws. I'm really happy with how those turned out. So in terms of the electronics, I've been going through and figuring out everything that I need to go inside of my electronics enclosure, and the very first thing was the CNC controller, which, when it comes to what I'm looking for, the CNC controllers for, I'm going to say like pro hobby grade. I'm straddling that range between, it's not just DIY, but it's not like industrial level. It's that gray zone that's in between. And so I don't know, pro hobby. My CNC controller, what's interesting is there's not a whole lot of options for good CNC controllers in that range. There's a whole lot of like, here's an Arduino kind of controller, and like, nah, I don't want that. But I also don't want to spend $800 on like a super nice enclosed DIN rail thing. It doesn't need to be that nice. I just need something in between that has all the features that I'm looking for. And the very first thing that I tried out was called an NVEM by Novosun, which is like absolute Chinesium, like the top tier grade A Chinesium. And I ended up getting it I purchased it maybe 2 months ago, and it arrived last week because it had to be on the slow boat. It shows up and absolutely doesn't work. I fired up. I get zero communication to it. It's communicates over Ethernet, which is something that I was interested in getting involved with because I thought it would be nice to have my CNC on a network, and then I wouldn't have to have a dedicated computer to the CNC. I could just use my laptop whenever and basically wherever. I thought that might be cool, so I figured let's give this Ethernet controller a shot. And like I said, I get it, and I probably spend 2-3 hours just trying to ping it, just try to get any kind of communication from it whatsoever. End up pulling it all apart, looking at the board. It looks fine, so I said, you know what, screw it. I'm going to take it over to my bench, and I resoldered the Ethernet connector on the board, bring it back to my computer, and it starts lighting up and blinking and doing all of its stuff. It's like, seriously? Like, that doesn't leave really good feeling in your stomach that you buy a brand new thing. I mean, yeah, sure, it's kind of Chinese garbage, but like if it had problem with that kind of soldering on it, it didn't really leave a good feeling about anything else. And even though I fixed that, it still wouldn't communicate. I was able to ping it, but I can't get it to talk and do anything. So there's some other issue with it. And above and beyond that, if I take it and just flex it slightly with my hand, I can make it stop communicating or stop basically just flashing the Ethernet port. So I just decided, you know what? We're axing this thing. It's low grade. It was kind of a hope because it had all the features I wanted. It literally had everything that I could want on my CNC. And most other controllers in this category or this price range are just they don't. So I ended up axing it. I'm returning it, and I ended up finding another controller called the STB 4100, which is also pretty much Chinesium, but a lot more. There's a lot more evidence of success. Let's put it that way on forums that I've read about, and it has like 98% of all of the features that the NVEM has. Some of the deficiencies it has, like the NVEM has individual inputs for the probe, for all of your home switches, for all of your limit switches. You don't have to parallel them. Well, with this STB 4100, basically everything gets paralleled, and that's fine at the end of the day, but it's not as nice. It is nicer to know when you or if you hit a limit switch, which one you actually hit. And the NVM had that capability, but this STB doesn't. Now, if you're homing, you know which one you hit, even though they're parallel, because you only do one axis at a time, so it moves the X, and if it sees anything, it knows you pressed the X, and then it does the Y, and then it doesn't.
That board is very inexpensive.
It is. And I was actually somewhat concerned about it because of how inexpensive it is. But I've done a bit of research, and other than the fact that it has just garbage documentation, people seem to have a lot more success with it. And one of the main differences, it's USB, not Ethernet, which the Ethernet thing was more fun, let's just put it that way, than a requirement in my mind. So yeah, I do have to haul my laptop over to the CNC and plug it in to be able to control things. Whatever, that's not a big concern.
Because I got to look at the board that's not working, which is the NVEM, and the big thing about that, what startled me was you can just tell that the solder quality is not very good on it. And it has a BGA component on it. So it's definitely something that didn't get... That board just was not reflowed right, is what happened.
Correct. And I probably, if I put some effort into it, I could probably get it working. Another requirement, though, is that I'm not the only one building this CNC. My buddy up in Connecticut is also planning on building one of these, and we're using mine as basically the test bed. Once I get this all done, we can package up like all the design stuff, and then he can build one. a big requirement from that is that I don't want to troubleshoot his machine. I want his machine to work. And if I had trouble with this controller, there's a high likelihood that he would have trouble with it, and I don't want to be tech support for that. So I'd rather just get something that's a lot more simple and executes on everything.
So where did you buy the NVEM from?
Amazon, actually.
Okay, yeah, because I just saw it on Amazon, but I can get it. I can get it by Thursday on Amazon.
Yeah,
It must have been
I
out of
probably
stock.
chose. I probably just chose the wrong listing, and I wasn't in any rush for it when I originally bought it. So
So this is the NVEM is $108,
yes,
but your new one, which
it's like
was
$30.
I think I've been finding them for like $15.
Yeah, that's also got me. I don't know. That seems iffy. Now here's the thing. I didn't necessarily want to go with a low end controller, and I keep using the word controller. They call them breakout boards. Basically all it is your software on your computer needs to be able to toggle pins. This is the board that allows you to actually do the toggling of the pins. I wasn't necessarily looking for a low end solution for it. I would be fine with spending some money. The thing that's interesting is in that gray zone, like I said, between hobby grade and like a higher grade thing, there's a real lack in my opinion. I haven't found anything that just scratches all the itches that I want, and so it actually ended up being that if I went down in grade, I basically got what I was looking for. Because the stuff that ends up that's a bit pricier, I found was lacking more of the solutions I was looking for. Because I want support for an MPG, a manual pulse generator. I want support for all of my limit switches and things of that sort. And then I want slave axis capability because I have 4 motors and I'm doing a dual drive on the X. And this board has all of that capability. In fact, what's interesting is this board actually only is missing one thing that I want, and I'm looking to find a way around that. If I don't get it, I can live without it. But basically, this NVEM had support for an FRO, SRO, SJO box, which stands for feed rate override, spindle rate override, or jog rate override, effectively. And basically, you could connect an encoder into this device, and then be able to on the fly control your feed rate and your spindle rate, which I've been seeing for over a decade now. I never really used that until my last job at WMD, where I used the feed rate override control on my CNCs all the time. It was super nice that if you were starting a new job or if you had a new program, you could start off really slow. You could watch the machine approach in the workpiece and go really, really slow. And once you felt confident, you could start ratcheting up the feed rate. That was a really, really useful tool that I never had before. Like most of the time, if I was doing a new project on my old CNC or even other CNCs, I would simulate it on the computer. I would make sure that I wasn't going to run into anything and build confidence before actually committing to a cut. But once I got to the table, you had to press go and you'd keep your hand on the emergency stop because it was going full speed in from the get-go. And if you made any mistake, which I have before, you'd run the head into something, or you would I've had times where I made a mistake and put the wrong thing in the wrong spot, and I thought the machine was going to move in one axis, and the Z just went right down into the table. Like I've had that before. But if you have a feed rate override that you can feather, you can watch what it's doing right away, and you have a lot more time to stop it if there's a problem. And having an FRO control as a manual box is really, really useful. The NVEM supported that. I have yet to find a controller out there that supports that option for any kind of reasonable cost. And that's one of the main reasons why I wanted the NVEM, because it kind of had all of the stuff together, everything I was looking for. But if it doesn't work, it doesn't work. I'm not going to look back on that.
So I looked at the Amazon reviews of the NVEM, and all of them complained about not being able to connect to it.
Uh-huh. Yeah. I feel like it's actually a nice product. It actually looks nice. It has everything you're looking for. If the manufacturing was better, this would be a really fantastic option. And there's a bunch of YouTube videos of people using them and they actually do function, but it's just that's iffy. I don't wanna chance it.
I wonder
So,
if basically Amazon got a bad batch,
it's
and
possible.
that's just until they go through them all. That's what you get.
Yeah, I don't know. Maybe. I wouldn't be surprised if they just it's inexpensive enough that they're just like whatever, screw it. People will return them and
Yeah.
if they want to. But so this new controller I have is going to do everything but that FRO control. I'm there's other methods of being able to do that. Like you can get USB pendants, which are like hand controllers. But that's just another USB thing that I'd have to plug into my computer to be able to use it. I'd rather have everything be a part of the box, the electronics enclosure.
Just put a
And
hub in the box then.
I could, yeah, I could, and then just split it. I don't know. That feels real hacky. It doesn't feel right to me. So I don't know. Right now, my solution is I'm just gonna not live with the FRO because I've been seeing for so long without an FRO. And if you really want to, with a keyboard and a mouse, you can control the FRO. So there is a solution around it. It's really nice to have a box in your hand that has a knob on it, so you can watch the machine. You can get up close to it. You don't have to be clicking on things. It's just right in one hand. It's so much faster than clicking on a screen to control software to do something that's ripping itself apart if you run into something. I'm, I've never gotten that far, but I've crashed a CNC before, and
I think
it's not fun.
everyone does at one point in their life.
Yeah, yeah. I'm really surprised that for how there's enough hobbyists out there doing CNC stuff. I'm surprised that there's not what feels like a better solution for what I'm looking at, the grade I'm looking at. Maybe I'm just missing it. Maybe I'm just not seeing it. But I've spent a while searching, and like I said, it either seems like, oh, here's a thing that you plug into an Arduino, and okay, great. If I had a 3D printer or something like that, fine. But I've got a big monster CNC. I don't want that. I want something that's more dedicated and more, shall we say, reliable and robust. It just doesn't seem to be there.
Says the person that's gonna put a $15 controller on their ginormous CNC.
Well, I didn't buy the $15 one. I bought the $30 one.
It sounds like you overpaid.
The funny thing is, I used a parallel port breakout board for years, and that never once had issues with it. The big difference between what I've used before and this is that this is USB controlled now, as opposed to parallel port, because I don't want to have a dedicated old computer with a parallel port on the motherboard, and you can't use a USB to parallel port converter for those things. It has to be like
parallel
legit
port.
parallel port.
Mm-hmm.
And I just want to get away from that for a lot of reasons. But okay, regardless, I now have a controller on order. All of my electronics need to go inside of a box, and so yesterday I found an enclosure by the manufacturer, or the vendor, I guess you could say, is Vivor or Vevor. And I found one that is 24 inches by 24 inches by 8 inches deep, and it is a NEMA enclosure. So it's a steel enclosure with with a door and with the pull-out thing that you can wire everything up in and then slide all your electronics in. I'm really hoping that this is actually a decent box, because the price on it was surprisingly low for what I was getting. I've been researching these enclosures, and you can spend a lot of money really, really fast on a solid enclosure like this. In fact, if I really wanted to get the enclosure that I was looking at, I wouldn't be able to buy from these guys because they don't make it large enough. But I'd need something much larger than this 24 by 24. Like, I was looking for like a big cabinet. because I wanted to do everything with cable trays and do everything right. It's going to be it's going to be a little bit less than what I was hoping for, but that's because of my wallet. Like I don't want to spend $1,500 on a NEMA enclosure for my CNC. This Vivor 24 inch by 24 inch end up being a little over $100, which is surprisingly cheap for what you get. So I'm gonna do a bit of a review on it. I think it arrives later this week, and I'm gonna inspect it pretty heavily before, because it was, like I said, it was a little over $100 with free shipping for a big box like that. I don't know. We'll see. Maybe I'm cutting corners where I shouldn't cut corners now, because I haven't cut corners on like anything else on this CNC, and now for whatever reason I'm doing that. We'll see. My inner hobbyist is coming out, I guess. But regardless, the challenge now is, this is the biggest box I could get for a price that I'm okay with paying. Now I have to get the electronics to fit, because a few weekends ago I actually did a drawing of all of my electronics that was to scale, to try to see what kind of box, what size I needed. And that's when I was like, oh, I need a really big box for this, because a bunch of switch mode power supplies, a VFD, your CNC controller, and all the other stuff that goes inside the box ends up being a lot of real estate that you need. So the challenge now is getting everything to fit in this 2-foot by 2-foot envelope. I'm going to try my best to keep everything spaced according to the data sheets. They say like 30 millimeters between drives, that kind of stuff. My goal is to just keep things spaced properly, but they may end up being closer than I wanted them to be. I was hoping, like I said earlier, to put cable trays in between everything so I could, wire it in the way that you see, industrial control boxes. But I don't know if I have the cash to be able to buy a box that big to be able to support that. So I think my concession with all of that is I'm going to loom all of my wiring as best as I can and tuck it away. It may be more exposed than I was originally hoping for, but I think I can still get the quality of wiring that I'm looking for, just maybe not with all the cable trays. So,
is there any reason why you're going away from the cable trays?
I can't afford a box that is big enough to support all the electronics and the cable trays.
Oh, you're talking about inside the box. I was thinking about the cable trays on the machine itself.
Oh no, I'm not relaxing on that. There's e-chain and cable trays for the whole machine on the outside. I'm talking about inside the box.
Gotcha.
I may have to space like drives and the controller and the power supplies close enough to each other that I can't support, multiple inches in between everything in order to get it. Really, my because I have all of the parts now, my plan is I'm going to get the box, pull the whatever tray out of the box. I don't know what you call that thing, but that steel plate basically. Put it down and just visually arrange everything until I'm like, okay, I'm okay with this. Mark armor holes, drill everything, mount it, and then wire it. That's my plan. I was originally hoping to try to model it not in 3D, but as like a 2D. Like here's rectangles that are the footprint of all the parts. And as soon as I started doing that, I needed like a 3-foot box. And then I started going to find NEMA enclosures that are that, and you're talking about 4 digits easily for just the box. And I'm like, I don't want to spend that much money on this. So I don't I don't want a sizable percentage of the whole cost of the CNC to be just the box. Because at the end of the day, it is just a box. So the only thing that the box that I need to interface with the box, there's 2 things. I'm doing a changeover switch, so the actual power to the whole CNC will just be a rotary switch on the side of the box. One of the big ka-chunk ones. Because it is 220 volt, and It's fairly low current, but I just want it to be a little bit more industrial. And then the VFD, what's annoying with the VFD that I have is when you apply power to it, it goes through an initialization, and then in order for for it to accept an input, you have to press the run button on the front of it. So the VFD, I have to break the front panel out and mount it into the door of the box. So the VFD I have, it has the control panel on the front of the VFD, which you can remove that control panel. It has even like little finger grips that you can pull it out. And then you put an extension ribbon cable. So I basically have to snake it through the box and mount it to the front panel. So basically the order of operation is turn the box on, wait a few seconds, press the run button on the VFD control panel, then the whole box is ready to go. I really wish I didn't have to do that. I wish it was just power on the box, but whatever. It's fine. The annoying thing too, this VFD, you control the spindle speed via a 0 to 10 volt signal. So the computer sends commands basically to the little breakout board, and that breakout board, or this controller like I've been talking about, generates a 0 to 10 volt signal that gets sent to the VFD. The VFD has an on and an off for being able to accept that signal, and that's purely manual. That VFD, you have to go and press the buttons on the box. If you fail to turn off the VFD's input acceptance, I guess you could say, and the controller gets unpowered for whatever reason, it can actually spin up the spindle. So it's a little bit dangerous in that sense, that the spindle because it's just accepting an analog voltage for spindle speed. So if whatever reason that gets hiccuped, the VFD will be like, let's go, let's turn on the spindle. So I want to be able to have access to that control without having to open the door on this NEMA enclosure. So, like I said, the basically all I'm getting at here is I need to break that little control panel out and have that on the door of the box.
Does it have enough slack to do that?
Well, no, like I said, I need to get a new ribbon cable for it because it has like 2 inches of ribbon cable right now. But I've seen other people do it with this exact VFD where they put like a 4-foot ribbon cable on it. So I'm not too worried about noise or anything like that. It just, you have to snake it all around the box. CNCs are weird because along with what I've been saying earlier, like there's hobby grade, which is bottom of the barrel. Then there's this huge blank zone, and then you start getting into like low grade industrial, and then from there you can spend as much money as you want. And like I said, I fit in that gray zone where your VFDs are kind of crappy, your controllers are kind of crappy, your software is kind of crappy. It's all good enough, it all gets the job done and is adequate, but it's just it always leaves a little bit where it's like, nah, that could be just a tad bit better. So I'm putting my effort and I'm spending my money on the things that really matter to me, and just conceding on all the other stuff. So so I get the controller in and the enclosure this week. I'm gonna start wiring as soon as I can on it, and as soon as I have stuff actually moving, we will I'll give another update. The next phase is getting the box all done up and getting that worked out. Then the phase after that is running all the wiring properly throughout the CNC. I am going to run the CNC, at least just move things, make sure it's all good without all the E-chain and the cable trays and all that stuff, just to make sure that it's all functional. So once the box is done, confirm everything's moving, confirm that computer's talking to it, then do all the cabling and make it all nice. And at that point, it's effectively done. All that remains beyond that is skinning the table. So I have to actually put the table part, which is basically just MDF across the table. It's sheets of MDF that are bolted to the table, and then on top of that, it's sheets that get glued down as the sacrificial pieces. And at that point, I would call the machine commissioned and done.
Well, I can't wait.
Yep, I'm looking forward to it. This is the fun part, even though this is the part that I'm like, like it feels a little like I don't know what I'm doing. It's still the fun part. I shouldn't say that. I do know what I'm doing. It's the part that is the least planned. Let's put it that way. Like I planned so much of the mechanical beforehand. I spent a long time making sure the mechanical was right. And like I said earlier, like it all went together like Legos. I'm super happy with that. But I knew the electronics were going to be a pain, and I kind of put them off for a while. And now it's like, well, now I'm in the pain part.
Yeah, you're paying for it.
Yeah, for sure.
Okay.
All right, so on to the next topic.
Next topic. So
the simplest SMT component in the world.
So this morning, opened up my email and got one of those like marketing emails from a distributor, Mauser in this case, and they're like, "Find the connector you want," or something like that. And there's like a list of like 6 connectors in there, but one of them was just a piece of gold rectangle, and I'm like, that's not a connector. And so I clicked on it, and Harwin, which is I guess a manufacturer of connectors and stuff, mostly like pogo pin style stuff.
They also do like 0.1 pitch headers.
Yeah.
Stuff, a lot of stuff like that.
Yeah, a lot of stuff like that. But these are surface mountable contact pads. And I'm like, this is just a weird product that I kind of just want to talk about. And I'm hoping we can kind of figure out maybe what these are used for. So the marketing material, so you click on the data sheet, and it's not actually the real data sheet. It's like the marketing family data sheet for it. And it says surface mountable contact pad, ideal as a mating area for spring contacts, spring-loaded contacts, and spring-loaded contact connectors, which is what Harwin makes. They make a lot of like pogo pin style connectors to where like, and spring-loaded stuff to where like when you drop a device into like a charging cradle and it has all those little contacts, that's what they make. So these are basically pieces of copper that are nickel plated and then gold plated that are just flat pieces of metal. And that I don't see what the reason is to use these, because where my brain first went was, oh, maybe they are better wearing than, let's just say, a ENIG pad on the board. So let's just say you had a copper pad and then you put ENIG on it. Maybe it wears better than that, right? That's what would make sense to me. The problem is you pull up the actual data sheets for these parts, and the contact pad's gold thickness is somewhere between 0.025 micrometers to 0.075 micrometers, which one's a big range, but it's even larger, or it's a smaller range, but it's still thinner than basically like the IPC 4552 standard for ENIG finish, which is like 0.05 micrometer to 0.2 micrometer of thickness. So yeah, I don't really see what the point is to this part. Maybe,
I mean, it's literally just a rectangle of copper that's been gold plated. It's 2.5 millimeters by 1.6 millimeters by 0.006 of an inch, so 0.15 millimeters thick. So it's a pad that you solder onto a pad.
Yeah, I maybe if you needed like a pad that came off the board more for like tolerancing reasons, but even then, like, even this part alone is its Z height is going to be more variable than just a copper pad with ENIG on it, because the solder underneath it's going to make it want to float a little bit, and depending on how much paste you put down is going to be kind of how what your Z height for this component is going to be. Maybe it's harder, like since it's actually like thick copper in it versus like a 1 ounce or half ounce pour on the board. Maybe that's where you're getting at it, where it actually will resist, like let's say, higher spring force than a copper pad. Like a copper pad on a board. I have no idea though, because it doesn't mention anything about that in the marketing material.
And it actually comes in multiple different shapes. It's not just a rectangle.
Yeah, there's
It's
round
got
ones,
circular pads and oblong pads, or
Yeah.
ovals.
Yeah, it's a really weird product because I'm racking my brain on when, and it's not like they're inexpensive either. They're still like 10 cents to 20 cents in quantity. So they're not exactly cheap.
Yeah, what would you use it for?
Like one thing in my brain was like, oh, maybe if they were inexpensive enough, maybe you were using like cheaper PCBs, right? Like that were like lead-free hassle coated, and you needed to put on gold contacts for like spring connects, right? But the price of these parts would not lend themselves to that.
Yeah, it just seems like everything that I'm looking up just seems like it points towards these are just meant for additional heft on a pad for spring contacts.
Yeah.
Maybe if you had like a snap dome and you put it underneath a snap dome, you'd have more. I don't know. I'm stretching here.
Yeah, I think
it
that's
just seems like something that's going to have repeated contact.
Yeah, but all the products that I've seen that have repeated contacts for these, they just use hard gold on a PCB.
Yeah. Interesting. I wonder if these work better. Like if you have a device where you solder these onto it and it's like a battery contact that instead of pressing down on it, it has to like slide onto it. Maybe there's something about that. Like a battery on a drill, like a cordless drill. You know how those have like fingers that come and connect in. Now that is probably a completely different design mechanism. You know, they probably actually have like bent contacts that do that. But maybe if you were designing something like that where it had to consistently slide in and you wanted it to be on the edge of a PCB and be thicker than just, I don't know, PCB plating, that might be a solution.
Yeah. I just wish they had like an application note or something with these where it would be like, this is a product that these get used in. Because otherwise it just feels kind of like it's a product looking for a solution, it feels like.
Maybe, just maybe, if you're designing a very inexpensive board, the 10 cents you would spend on this for this product is cheaper than e-nigging another board. So you're putting all your e-nig in one spot, basically.
Yeah, that's what I thought. I just don't think that's works out.
Maybe not. Yeah, the language says here surface mountable contact pad, ideal as a mating area for spring contacts and pogo pins. Or maybe it's something where you could use these until they're damaged, unsolder them and solder a new one on, and you don't damage a expensive board. So they're replaceable.
Yeah, but that would be in like the marketing material. Like they're not giving us anything of like what we should be using these for.
It's like they just paid a guy, with a strip of copper to just sit there and clip them off.
So
What?
I'm hoping our listeners out there will take a look at this. We'll put the like links in the show notes, and like maybe someone out there's got like a idea of what these are actually used for. Like I could see like if you needed like a little bit more Z height for these spring contacts, like that could be the reason why. But again, that's not in the marketing material.
And it's only 6 thou, so
They're not.
tolerance almost becomes a problem at that point.
Yeah,
Now, on Harwin's website or the page for these, if you go to the related products section and go to the mating thing, so their suggested mating contacts, it's all spring post or spring loaded like fingers and things like that. So basically, like I was saying, if it has to slide into something, they're suggesting that.
Yeah, just I've seen a lot of products that do that sliding motion, and they just use a PCB in there with a Enig plating on the pad.
Right.
So the only thing I can think of is if you had so much like contact force, like let's say you had a spring loaded contact that you had to pass a lot of current through, so you needed a high spring retention on there. This might be the use case because it's probably stiffer than just the normal pad thickness. That's again, I'm reaching
We're
here.
stretching here.
Yeah.
Yeah, it seems like all of these things that we're saying you could design around mechanically.
Possibly, yeah.
Well, it exists for a reason. Somebody asked for it, and somebody buys it.
So yeah, somebody. Well, we don't know if anyone buys it, but
I would assume that if it's active, somebody's got to be buying it. Who knows? It is kind of funny too because you could download a CAD model of it.
Yes.
I guarantee it's just a rectangle.
I was about to mention that.
That's amazing.
So, but I do think this is the simplest SMT component in the world. It is
You can't get simpler than this.
piece of copper that is plated nickel and then plated gold.
Has really good temperature range. Goes all the way up to 180 C.
I bet you it goes way higher than that. Could you imagine the test engineer that had to run that test?
Yeah, you just put it in the oven. Yep, it's good.
Yeah, that's good.
Check, pass.
You have anything else to say about Harwin's surface mountable contact pads?
I don't. What more is there to say? Other than I would love for someone to just be like, "Oh yeah, I use those all the time, and here's why."
Yeah, I hope someone listening is like writing a furious email at us right now,
Furious.
and I get to read it over the weekend.
Yeah, that'd be fun.
I think we'll just cut off the podcast there. We're at almost 50 minutes.
Oh, all right. Yeah, sounds good.
So we'll see everyone next week, and that was the MacFab Engineering Podcast. We're your hosts, Parker Dolman.
And Stephen Craig.
Later, everyone.
Take it easy.
Thank you, yes, you, our listener, for downloading our podcast. If you have a cool idea, project, or topic, let Steve and I know. Tweet us at MacFab, at Longhorn Engineer, or at AnalogENG, or email us at podcast@macfab.com. Also, check out our Slack channel. You can find it at macfab.com/Slack. Okay, stopped. Yeah, I'm 99% uploaded too now.
Milmax produces them as well.
I wonder if they're... So, a lot of companies do this, where they will rebrand other companies' products to fill out their catalog. Not saying that's the case here, but I really want to know who uses these things. Because at first I thought it was going to be like a test point that you like stuff, but it's no, not really. Yeah, I've been looking at that Crossfire plasma table.
Oh yeah.
I mean, I don't have space here, but at my new shop, I'll have plenty of space.
Huh. There's another place that actually multiple places I'm seeing. They call those female pogo pin connectors. The pogo pin that actually has a spring in it is the male.
I mean, that
Weird.
part makes sense, but actually, I've never heard of a gendered term for a pogo pin.
I wonder if they're just you use them to extend the life of a pad. It's got to be.
That's that's what I'm thinking. But then they would have like, oh, a pogo pin can be rammed into this thing a million times. But they don't even have a life cycle, like a contact cycle for it.
Yeah.
Maybe it does. Let me check the actual like PDF. I just missed it. Um. Okay. I also have another idea. So I'm reading the customer information sheet. This is that big PDF with like the dimensions and stuff on it. And it says drawing number, blah, 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 blah. The next box says, if in doubt, ask. I've never seen a drawing ever say that. Now it's made out of beryllium copper. Is there a specific reason why they would call that out? Is beryllium copper harder than normal copper? It's stuck. So beryllium copper is also known as spring copper.
Maybe it promotes connection. Maybe it's softer in it.
Because beryllium copper is used to make tools for non-sparking environments. Like if you need like a monkey wrench in like the oil field, it's made out of beryllium copper. So they're harder than normal copper. So maybe it is with like it is a wear thing.
Yeah, I'm reading an article right now that's talking about them.
But the one thing I can see on this that would make sense is it actually gives you a contact resistance.
A known contact.
A known contact resistance. It says 0.15 milliohm max. Doesn't give you a range, but it gives you a maximum.
Yeah, this article is saying the discs are typically placed on solder-pasted PCB pads and then subjected to reflow soldering. Once soldered, the terminals are ready to be used as a reliable, durable contact point.
Still doesn't give us what that means over a normal pad, though.
This is interesting, though. I'm going to send you this. I'll send it to you in Slack, this article.
It would be harder, though, because they're made out of beryllium copper versus copper flashing, which is on PCBs. So it would be a harder material, base material.
Well, their marketing material shows spring contacts on there, but it also shows test probes on, or like at least as just an example. Maybe I know it seems a little bit goofy. I'm stretching here, but maybe if you have a thing soldered to it, it makes it a very obvious test connection.
Yeah, but you would just use like a normal test point.
I'm just saying, maybe I don't know. I'm just stretching here based
See,
off of their image.
so the Milmax ones that you just sent me make more sense because they're taller.
Well, they make a variety, but yes.
Yeah, but they even the short ones are taller than the ones that Harwin was are making.
Yeah.
Like you're talking 25 mils for 6. Which again, that makes way more sense if you have like a Z offset that you need to like bring up contacts. That would make sense.
You know, like what are they called? Earbuds. You know how they usually have a little case that's magnetic and you stick them in there? I bet you these targets give you a little bit of extra Z on that, and they give you a lot longer life on them, that such that you don't have to have the PCB right up on the. Like, actually, that totally makes sense if you have a thickness
for
they can
these
poke through.
The Milmax targets for sure.
Yeah. For the other ones, I agree.
But not the 6 mil thick Harwin ones. We'll see if someone's got to be like, this is what they're used for.
I mean, the thing is, we know what they're actually used for. They just don't make sense.
That's true. So, and it's interesting, the Milmax ones are actually brass. Brass, the nickel plated. But then they're also using, Milmax is using 10 micrometers of hard gold. So it's even thicker. It's got thick gold on it. That's the whole thing. These Harwin ones they have a thinner than the Enig finish coating on them. But they are made of beryllium copper. I wonder if beryllium copper is harder than brass. I'd imagine so. Why would you make a tool out of beryllium copper versus brass? Because both would be non-sparking, right? Brass doesn't spark.
In terms of Rockwell, they sort of span the same. Well, no, beryllium's copper is on the higher end of brass's hardness range.
Beryllium copper is more conductive because it has way more copper. I think because it's like 99 point something % copper. Interesting.
Brass is harder than stainless steel. I didn't know that.
Interesting. I think I'm going to shut down the stream.